All right, so today we're going to look at some accuracy. All right, so what we have just done is we have a bunch of data on a grid. All right, so what we are going to do is obviously if our catapult had perfect accuracy, it would hit 0, 0 every single time. But that is not the case. We obviously um, had a range of values. So we want to look at where the center would be based on our values. Okay, so I have some values right here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I have 10 values. Um, the first method that we are going to use is a long piece of string. Form the smallest circle you can around all of your marked landing locations. All right, your circle will likely not be centered at the origin. Okay, so what we have found is it's easier to use a pipe cleaner versus a piece of string because it's easier to make a circle with it. So what we're going to do is we are going to, step one, kind of estimate the size of circle needed. All right. So for mine, I'm going to need about this size circle. And then what I'm going to do is I'm going to place it on here and encompass all of my 9 points and try to make it to be a circle as best I can. See how I'm not distorting that circle or making it like this to fit the points? I am doing my best to keep the circle as uniform as possible. All right. Then once I do that, I want to estimate my center point based on that circle. So right here, what I have is my center point based on the circle of my data. Okay. So yours obviously will be different because we have 20 bits of data and you're going to need a larger piece of string or pipe cleaner. You might have to attach a couple pipe cleaners together. But this right here is going to be my estimated center. All right, so if we look at this, see how that's -1, -1. So my estimated center is -1, -1. And then what I'm going to do is measure the distance from the target to the center of the circle you made. All right, so right here, all right, I'm going to measure this distance. All right, and that is going to be the device error. So here to here. So I will measure that with a ruler. Okay, and I got a estimated device error of 1.25. All right. So method two, you are going to use your spreadsheet. All right. You are going to use the average function. And then you are going to calculate the distance between the targets. So once you find these centers, all right, you are going to use a little bit of math. So one of the sides, another side, and then you are going to find this side of that triangle. Okay, so we'll talk more about that in the spreadsheet. So then we're going to talk a little bit about range. All right, so the range will be used to estimate the precision of our device. Okay, so a quick estimate of the range can be found by measuring the diameter of the circle. Okay, so if we go back here to our circle and measure the diameter, so all the way across of that circle, if I look at this, mine goes all the way to 6 and over to 4. All right, so and that happens to be pretty close to my diameter, so right in the middle. So I would say my diameter is 10. All All right, so 10 inches. Now, this is the somewhat tricky part. All right, so now for our next activity, we're going to use this device to set up our carnival game. Okay, so what we need to do is we need to have 25% of the bags launched should hit within the inner bullseye circle. So for me, 25% of 10 launches is between 2 and 3 launches. All right. So I'm going to say 3 launches. I want to slightly overestimate. So what I'm looking at is my center. Okay. And I'm looking at my 3 closest launches. So what I see is this one, and maybe this one. So I'm going to make a circle that is that size. So I'm going to make a circle as small as I can to encompass those 3 points, because for my 10 data points, that is about 25%. For yours, you're going to have 20 data points. So 25% of 20 is your inner 5 data points. All right. So this right here, if you count it, 1, 2, 3, 4, 5, 6, 7. So my diameter right here is 7 inches. Okay. So this, for me, would be a bullseye circle of about 7 inches. Okay. So then if I wanted another 50% of the beanbags should hit between the inner bullseye and the outer circle, then what I need is I need to make 2 circles. So I need to make one that's right around my inner circle size. Okay. That's going to be right around 1, 2, 3. So if I do this and make my circle right about that size, all right, then my next one, 1, 2, 3, my next one has to fit the next 5 bits of data. So I have 1, 2, 3. So my next ones are 1, 2, 3, probably 4, 5-ish. All right. So my next circle is going to encompass my next 50% of data. So for me, that's about 5 bits of data. For you, that's going to be 10 bits of data. All right. So I'm going to try to make my circle so that it fits my next 50% of data. All right, so if I do that, I'm going to get really close to 5. So 1, 2, 3, 4, 5, and 6. So I'm going to get really close to 11 inches there. All right. So that's how I kind of get my inner bullseye, 7 inches, and my outer bullseye, 11 inches. So my predicted bullseye radius here would be 3.5, because that's half of 7. And my predicted outer circle radius would be 11 divided by 2, which is 5.5. Okay?